Okay, we started recording. Now, where is it? No, this is not it. Yes. Like I told us earlier, I said variable is the name you give to the location where data is stored. Now, it is just a reference. It is not the place where the data is stored per se. Now, what type of data can be stored is available in Visual Basic? The first one is Boolean. Now, in life, generally, there are some situations where the only answer to a question is either true or false. No sitting on the fence. That is what this Boolean is standing for. Just true or false, 0 or 1. You understand? Boy or girl, good or bad. Something as simple as that. No long stories. So, come on, please. I have to admit something. No long stories. So, now, where is it? Okay, so another data type we have is the byte. You understand? Unsigned byte. So we have the characters as well. The characters. These characters, they are basically just one. We have string, a collection of characters, but char is just one character. All these data types, these are objective questions that they might be asking you, cheap objective questions. If you don't know them, you'll just be there losing marks. So you are supposed to know all these things. You are supposed to know them. So we have the decimals as well. Please mute your microphone, please. Mute your microphone. We have the decimals as well. So I think this is the range of the decimals available. So 79, I don't know. I know that this is 1,000. Then after this one, I think this is million. This is billion. This is trillion, 4,000,000,000, 50,000,000,000, 60,000,000,000, I don't know, 7,000,000,000, whatever. So now these are the range of decimals that you can store in VB, in Visual Basic. Now we have the double. So apart from decimal, we have double. This is the size of space it occupies in memory. For example, some of the movies we watch, some like the ones we download on Net Nigeria, it may be 165 MB, the storage space required. It might be 300 MB, but for a decimal to be stored in memory, it is just 16 bytes. And for the double, it is 8 bytes. These are objective questions you should not miss. You understand? These are objective questions you should not miss. So we have the integer. This is a floating point number. This one is the floating point number. But as you can see now, this decimal can store in only 28 decimal places, while this can store as far as maybe 308 decimal places, I guess. So this is the integer, and this is the range of integers that VB can calculate. This is 2,147,483,648 for the signed integer. Don't forget. Now we have the long as well, 8 bytes. So just go and read through all these ones. I'm very sure it's something you should be able to get a hold of by yourself. Now, if you take a good look at the table like I told us, you notice that those data types can be grouped into two. Now, in programming generally, data types can be grouped into two parts. The first one are the numeric, the second one are the non-numeric. You understand? I believe programming is mathematics, if you ask me, because you deal a whole lot with numbers. You understand? You deal with numbers a whole lot. So that is why one segment of data types is all about numbers, while others are all about non-numbers. You understand? We have
Chris.
I'm yes.
Join class. Can you permit them to join, please?
Ẹnì kan péré ló wà níbí.
Wọ́n wà ń díẹ̀ mi jọ kọ́ máa bá mi máa wò jọ.
Ó lé àwọn èèyàn wà níbí 69 èèyàn mò ń rí níbí.
All right, ẹ thank you. Sure, you see now, see how many people want to join now.
Oh no, ni wọ́n ṣẹ̀ṣẹ̀ join ni. Ṣebó ni mò ń wò yìí.
Ẹ ṣáà máa bá wa máa kẹ́ẹ̀tàn ẹ ṣé.
Tá.
Thank you.
So, no yawa. Where was I said? Okay, so that's the reason why, like I told us, we have the numeric data type. There is a section, a type for it, and the non-numeric. Now, the numeric data can also be grouped into two types. We have the whole numbers and we have the floating point numbers. That is the reason why I put here that we have integers and we have decimals. You understand? We have integers and we have the decimals. The integers are whole numbers, basically, while the decimals are the floating point numbers. Something point something. You understand? I will give you a good example of integers. If we have people in a particular room and you want to count them, you'll be counting as an integer because one full human being is 1, another full human being is 2, another full human being is 3. You understand? Discrete data types, that is what we call them in mathematics. The data type is discrete. Those of us that will be doing statistics in year 3 or something, you'll be introduced to discrete and continuous data. So the discrete is the whole number. Whole number 1, 2, 3, 4, 5, 6, something. But the continuous data types, they are these floating point numbers, you understand? Like weight, height, all those things. They are continuous, they are not discrete, you understand? So non-numeric data includes all these Boolean, char, date, object, and string. So the, what do they call it? The integers, which are the whole numbers. We have the integers, the short, long, and unsigned. You understand? I will put all these things into use at some point. So, hope there's nobody at the door. Okay, there's nobody at the door. So, non-numeric data types. We have strings, we have characters, we have booleans. You understand? The string is a collection or sequence of many characters. I will give us an example. Our names, you understand? Our names, for example, my name is Christian. So, my Christian is Christian, a collection of characters. You understand? That is a string. But if you want to say I, just out of the Christian, for example, CHRI, you understand? All these individual characters, if you want to store them in Visual Basic, you use char, the char data type, CHAR. But if you want to store a collection of characters, that is when you use strings. Now we have the Boolean data types as well. Like I told us, it's a data type of 2 states. Just 2 states. Please mute your microphone now. So let's continue. Okay. Data types in Visual Basic. Okay. So we come across all sorts of data types in our daily lives. For example, we need to handle data such as names, addresses, you understand, money. This name now, like I told us, this is non-numeric and this is a string. We have the address as well, which is a string. We have money. I told us, see money now, if your bank wants to send you a alert, if your bank wants to send you a alert, they will not send you a whole number as your account balance. They will send you a decimal number because even money itself is not a discrete data. Money itself, amount, money is not a discrete data. You understand? So we have dates as well. Dates. We have stock quotes. Those of us that are doing, what do they call it? Forex trading. I think I have MetaTrader here. Let me show us. I want to show us the, what do they call it? The quote and, what do they call it? The bid and ask price. All these things they use in Forex. They have to store them somewhere before they can be able to bring them out. I'm coming. My MetaTrader, no one open now. So you see all these things that are here now. You can see them. They are all decimal numbers. These are floating point numbers. They are not whole numbers. You understand? The bid price and the ask price. All these things. None of them is a whole number. So I believe you understand. That's just what I want to show us there. We're close now. So we have statistics and so many other things. So similarly in Visual Basic, we have to deal with all sorts of data. Some of the data can be mathematically manipulated, while some are in text forms. You cannot perform calculations of them. So like I told us, okay, we have the numeric data types and we have the non-numeric data types, like I've told us already. So numeric data types. Now let's start with the numeric. Numeric data types are types of data that consist of numbers alone. Numbers alone. Now these numbers can be grouped into the into discrete and continuous. Now, but Visual Basic doesn't recognize them as discrete and continuous. That is statistics. In Visual Basic, we have the whole numbers and we have the floating point numbers. You understand? Now, example of numeric data types are height. This is continuous. We have weight, also continuous. I think share values are continuous as well. I don't know. The price of goods. Well, if you are somebody that makes a whole lot of purchases in dollars, you see that most times instead of $10, you might see something like 9.99. They don't want to. It's just 1 cent to get to $10. But since it's not up to 10, you want to buy. You think it's a giveaway. You understand? So we have monthly bills and others. In Visual Basic, it is grouped into 7 types. So calculations that only involve round figures. Yes, like I told us, if it is round figures, discrete data, so you can use integer or long integer for the computation. Programs that require high precision calculations, we use single and double decision data types. Okay. They are called floating point numbers. For currency calculation, I think currency itself has its own data type. So they used to ask this question very well. Data types. You will think it is the wrong answer. After they ask the question, the last option will now be none of the above. You will think none of the above is the answer. You won't know currency itself has its own data type. So please take note. Okay. So we have the bytes. So byte. So byte is just one. What do they call it? Just one byte. All this storage, at least know the one for integer, long, single. You can actually know everything. For this one now, I think the range of values, they cannot ask you beyond that of byte and that of integer. So at least you can know. You should know all these ones. You should know them. But all this storage, expect anything from here. You understand? So these are the amount of space you will require to store the variable. Like I told you already, to store the data rather. Variable is not where you store data. Variable is just the name you give to where you store data. You understand? So variable is not what you use to store data, but the name you give to the place where you store data. Like I told us. So the space where you reserve for data, the amount of bytes that you require to store that data, that is all these ones here now. The memory space required. Now let's go to non-numeric data types. Non-numeric data types are data that cannot be manipulated mathematically. Like I told us, you cannot perform mathematical operations using them. So non-numeric data comprises of the string data type, the date, the boolean, that can only store 2 values, which is true or false. Then the object, the variant data. This variant data too, they used to ask it. Did they ask Anwela? This variant data. So please. Now, data type. Now, this string, they used to ask this one too. I beg. Have it at the back of your mind. They used to ask this string data type. What is the length? What is the length of storage of string? Now, the length of storage of a string depends on the length of the string itself. You understand? Because now let me ask us something. If it is only this numeric I want to pronounce, this numeric, only numeric, can take me just 3 seconds to pronounce maximum. But if I want to pronounce everything here, it will take me more than 3 seconds to pronounce everything here. That is just. Oh my God, I need that follow. Where is my? Oh God. So non-numeric data types. I was trying to explain this length of string. So the more the length of the string, the more what do they call it? The more space required to store the data. So the range of characters is between 1 to 65,400 characters per string. So for the fixed length, for the variable length, I think this is 2 billion characters. So they're just all these ones. I don't think they used to ask for it. So for this date data type, we have January 1 to December 31st. This is the range of dates that you can store in VB. So we have the boolean. I think I made a mistake here. This is HTML. Nothing. Come on, please. I don't think I need this. I don't think I need this, and this. Okay. So all this rubbish, just go and read it. Now, managing variables. Variables are like small boxes. Like I told you, very good. They are small boxes, just like in post office. The content of the variable changes every now and then, just like the mailboxes. So in terms of VB, variables are areas allocated by the computer memory to hold data. I'm sounding it now. Variable is not where you store data. It is the name you give to the place where you store data. You understand? It's like the label you give to the place. Now, like the mailboxes, each variable must be given a name. To name a variable in Visual Basic, you have to follow a set of rules. You understand? These are the rules you must follow to name a variable in Visual Basic 6. Now, the following are the rules when naming the variables in Visual Basic. Number 1, it must be less than 255 characters. But I want to ask you, if not that you are insane, you want to store a variable name, and you have like, I don't know, that 255 characters. It's like naming somebody paragraph. Like somebody's name should be a paragraph. Just think of it. I know Oluwa possibly. I don't know. I don't know all those long names. Names that are like paragraphs. I don't know. You want to name somebody's storybook. So why should you have as much as 255 characters? You understand? So no spacing is allowed between variable names. I will explain this one. No, not part. Yes, ma'am. Yes. Let me just explain everything. Then, when it gets to where we declare variables, all these rules, I will put everything into test. So it must not begin with a number. Variables in Visual Basic cannot begin with a number. It can only begin with a letter. You understand? Numbers 0 to 9, letter A to Z. You understand? Variables in Visual Basic cannot begin with a number. So period is not permitted. Period is that full stop. Period is full stop. And you cannot use exclamation mark or some special characters like at, this, and I think this will be ampersand. So the dollar sign, the pound, and whatever. So now examples of valid. Okay, cannot repeat the same. Yes. So I want to ask. Is it when you don't have score? You are the father. You gave birth to twins, and you named the two of them. This one, his name is Chinedu, and this one too, his name is Chinedu. The same father, even if they are not twins. Egbon jẹ́ Chinedu, àbúrò náà jẹ́ Chinedu. Doesn't make sense. You understand? So within the same scope, you cannot have the same variable name within the same scope. You understand? So examples of valid and invalid variable names. So I have some here. Valid name is my car, and an invalid name is my. Then we have period here. Car. So I think someone is at the door. So my car. We have my period then car. So this year, this is permittable. You understand? But you see, one new boy. No, we don't want. We don't want. So long name can be used. This one is permitted. But you see this ampersand sign. You are supposed to know all these things. Reasons why some variable names cannot be used because they may ask it. Then they ask Anwela. You understand? And you know your exam is CBT. So all these things are things they will do to deceive you and all. So first, you see this one now is what spoiled this one. This space bar here. Now encounter this one. Address space, this space bar, you don't work. They don't want. So is smoke is permitted. Now, declaring variables explicitly in Visual Basic. Now, in Visual Basic, it is a good practice to declare the variables before using them. In programming languages, basically, it is a good practice. In fact, if you don't declare a variable, and at some point you are referencing it, you are going, if it is in Python, you are going to be getting something called name error. You understand? You are going to be getting something called a name error if it were in Python. So, They are normally declared in the general selection of the code window, blah blah blah, using the dim statement. This is what they call them. So you can use any variable to hold any data, but different types of variables are designed to work efficiently with different data types, depending on the type of data you want to store exactly. So please mute your mic now. Mute your microphone. So now the syntax to now who did that now? Mute your mic. So the syntax to declare variable in Visual Basic is dim the variable name as the data type with which you want to the data you want to store in that particular space in the memory's location. So if you want to declare more variables, you can declare them in separate lines, or if they are of the same data type, you can declare them on the same line. You understand? So separating, for example, you can say the variable name as data type 1, the variable name 2 as data type 2, variable name 3 as data type 3. So this is one way you can. This is very valid. This is very valid. Declaring multiple variables of different data types on the same line. It is very valid. I've never come across a question like that before, but who knows? The first starts for a time. So examples of variable declaration. We have the password as string. You understand? Password will obviously be a combination.
We can't see your screen anymore.
Why can't you see my screen anymore? Okay, sorry. Can you see my screen now?
Yes.
Okay. So let's go back. Now, the password as string. Password is will obviously be a collection of characters and which can include numbers. Come, please. One second, please. Okay. Who's at the door? So, password will be a collection of characters like numbers, strings, special characters, and all. So your name as well is a string. If you want to add two numbers, for example, your first number and the second number as well, they are integers. They can be floating point numbers as well. So total as integers, the due date, whatever. So you can declare all these ones multiple this thing on the same line. You have password as string, your name as string, first number as integer, every like that. We are still going to be doing quite a number of times on. So we have constants. Now, it is not every time that the data you want to use in the program that it is a variable kind of data. Now, we have some constants. For example, in math, even in physics, we have a whole lot of constants. Like we have the gravitational constant. We have what do they call it? Hooke's law. That E that is here. No, that K. I think Hooke's law. F equals to K. The K there. I can't remember the name of that constant. So all these constants, all these things, they have their. It is not necessary you store them as variables when you want to work on a particular equation or whatever in VB. But pi, for example, pi is 22/7 from today till tomorrow. You understand? So it's not. Since it will not be varying, kind of. So you can just declare it as a constant. Now, constants are different from variables in the sense that their value do not change during the running of the program, like I told us. So to declare a constant, this is the syntax here. Constant, the name as data type equals to value. You understand? Constant, name as data type equals to the value of the constant. You understand? So now, assigning values to variables. After declaring variables, it will not just be there bearing the name variable. You want to store data inside of that variable. Out there's nobody. Okay. So you want to store data inside of this variable. So what you do is that the format is that the variable equals to the value. For example, you can do something like area equals to 34, or you can say area equals to, I think it should be pi r squared. Pi is 22/7, r squared, the r here is the radius. It can be an expression and it can be a single value, you understand? So the variable can be declared, this one, the expression could be mathematical expression, a number, a string, a boolean, or whatever, this value. So the following are some examples of variable assignments. The first number equals to 100. Second number equals to this. You understand? The username equals to John Leon. X equals to whatever. Pi equals to 3.142. State equals to Lagos State. All these things. All these variable assignments. Now, let's go back to our listing and do some variable assignments. I can do something like, let me do REM. Now, the variable declaration. This is the variable declaration. So I can say the name as as string. I can call name equals to Christian. So I can do someone is at the door. Jumper. So console dot write line. All these functions that are here, I'm still going to explain everything, so you don't feel lost. Write line name. So I don't think I need all these lines here. I don't think I need them. So if I save this and I run my code, you see what I'm having? I'm having Christian here. If you take a good look at this particular program here, I said the first line is declaring the variable name. The second line is assigning the value Christian to name. And don't forget, it might be an objective question as well. Assignment operations in Visual Basic, in programming generally, is done from right to left. Assignment operations in Visual Basic generally are done from right to left. You understand? So because this is right and this is left, this is an assignment operation here. I created a variable name as name, then I assigned the value of Christian to the variable name. Console.writeLine name. I'm calling a function called console.writeLine. Console is an object, writeLine is the method inside this object, and name is the value I want to output to this console. And don't forget, name is carrying the value of Christian. So it is more like saying console.writeLine Christian. So it's going to be writing Christian for me. Don't forget, I told us that this last line here is to just make the program wait. If I don't put the line here, this window now, it will just come, execute the right line, and it will go lower. Let me try it. Let me put REM. Comment that one out. Save and run my code. You see? Okay. Even execute, I don't know safe. It will just come very, very sharp. You understand? You can see it. It will come just, but if I put this console or read line here, it is going to be thinking I want to enter a value into the computer, into the program. So it will just be there waiting for me to enter something. So I don't want that window to close immediately. That was the reason why I had to put this console or read line to save the program back. So let's come back here. Someone is here. Okay. So we have the numbers. Okay, let's use this one. First number and second number. Let's use the first number and the second number. Just a simple mathematical operation. I can do something like, let me delete this. I can do something like dim x1 equals to, dim x1 as integer, integer equals to 31. So I can say dim x2 as integer equals to x1 minus 37. Console dot write line x2. Save and run the program. You see what I'm having? I'm having minus 6. You understand? What I did here is dim x1 as integer equals to 31. I declared a variable x1 and I said, okay, x1, you will be pointing to the memory in location where 31 plus 31 is stored. So dim x2 as integer equals to, I'm telling x2, okay, that memory in location where the value of 31 minus 37 is stored. 31 minus 37 will give you negative 6. And that is what I got here. That is what I got here, negative 6. So this read line, I hope you know what it's doing. So close this one. Sorry. Oh God, this one has so all these ones too, they are just there. Now, operators in VB. We have various types of operators in VB. We have the assignment operator, we have the arithmetic operators, we have the relational operators, and we have the logical operators, yes. So those are the operators we have in Visual Basic. So the assignment operator, as in this operator here, this equal to sign. The assignment operator, as per this equal to sign that is here. Oga, mute your mic, abeg. The assignment operator, this equal to sign here, this equal to sign, assigns a value to the variable. Now, a variable is a placeholder, like I told us, for a value. Actually, this is wrong. A variable is a placeholder. A variable is not a placeholder. A variable is the name you give to the placeholder. So, in mathematics, the equals to operator has different meanings. In an equation, the equal to operator is an equality operator. So the left side of the equation is equal to the right one. For example, I can say x equals to 1, console.writeLine x. This is what I used to comment out print 1. So okay. So console.writeLine x. X is carrying the value 1. So this is going to be printing 1. Let us go and try it. Let us go and try it.
We can't see your screen.
Why can't you see my screen?
Yo, bro. I can see your screen.
You should be able to see my screen now. You should be seeing my screen.
Yeah, sure.
I'm still presenting. I'm still presenting. Madam, you don't see him?
No.
You should just move your screen. Yeah. Move your screen to the right side or to the left. You'll be able to see it.
Okay. That's why you should just move your screen like this. Just move like
the Manuela girl should move her screen either to the right or to the left to be able to see it. She should just continue moving it.
Yeah, I think that's true.
Madam, are you with us? Move your screen like this.
I'm moving it. I can't see none. I'll leave it and join again.
Okay, I'm waiting for you to join.
Hello, J Baba.
What to
Hello,
do,
boss.
Baba?
I beg. Shey you go drop this PDF?
PDF. I never know if I go
Yeah.
drop am.
Sir,
After-
sir,
after-
please drop
I swear, it did letter.
I beg, let us drop the PDF. I beg.
Those that
Why you
pay
doing it?
like us,
Drop am.
sir,
Hello, we need the PDF.
we need it to
Please let us drop the PDF.
so
I beg, get that drop am. Hello, why you dey smile?
Ànírógun ẹkún o, ẹ̀ṣẹ̀ tún ní kí n rẹ́rìn. Àbí
I
wèrè
can see it
lélẹ̀.
now.
you can see it now.
Okay, thank God. Why am I laughing? You're asking me why I'm laughing. Oga, comot your camera. So let's continue. So the PDF. No worry, make I the think am first. Let's continue with the class. So console the right line x print 1. So let's go and try it. So carry out this one. Come out. Please, I hope you guys are seeing all these things as tiny as it is.
Yeah, sure.
Oh, na manager, my beg. I'm recording the video, so even after now, you
No,
get
it's
the
just
video.
anything.
Just for you to zoom in, that's all.
You can zoom in.
Just zoom in.
How can I zoom in Visual Studio? I've never done it before.
So just zoom in.
Wait. What's in the landscape? Where should I go to? Okay. You can put your phone on landscape.
You can put your phone on landscape too.
Yeah, landscape.
Let me see if I can 315. Let me see if I can what did they call it? Preferences. I'm looking for preferences. There should be a place for settings.
Yes.
Preferences. I can't see preferences anywhere here.
Bro, I beg, make she draw herself, Joe. Make she draw herself.
Oga, calm down. Wetin happen? I can't see view. I don't know.
Preferences should be at that edit side.
And that edit side. Shebon lele. Man, I know vex. The next class, I'll sort all these things out. I'll sort them out. So, dim. What am I doing? Dim x as, let me say 12 for example. No. As integer. When I know vex, so now Python at the right to all these 5 naira mistakes. I'm not used to it.
Python, Baba.
Then you mature. So the x as integer, then I can say x equals to 1. What exactly am I trying to explain? Someone is here. Okay, so x equals to 1. Console the right line x. Where is it? So console dot right line x. Close, save, and run the code. You see? That's the same way the mystery PDF. So now see this expression here. This expression here. You are increasing the value of x by 1. That is what we have here. This particular x equals to x plus 1. It is just long story. Just know that you are increasing the value of x by 1. Don't forget, I told us that assignment operations in VB are done for if I have something like x equals to 1, for example. Now, the assignment operation, like I told us, is going to be done from left to right. This is the direction. You understand? From left to right. So, if I have something like, let me close this thing. That's my razor. So if I have something like x equals to x plus 1. The plus f don't look like times. So if I have something like x equals to x plus 1, it will first of all take care of this one first. You understand? It will first of all take care of this x plus 1. And if x was initially 4, for example, it will be 4 plus 1. Then anything I have here, it will do this calculation and assign the value to x. Shall we get? It is done from left to right. So that is what is happening on this particular line. So let's go and implement it in our code. So back to this one. So now I have turning color. So x equals to 1. Then we have x equals to x plus 1. Save this and run it. You can see now x is now 2. Initially x was 1. So
Please, you can't hear your voice. So.
you cannot hear my voice. Okay, use earpiece now. You dey hear? Abeg, use earpiece. Everybody dey hear now. You can all hear my voice now. Abi?
Yes, we can hear you.
So let's continue.
Oh,
Can you all hear me? Una dey hear me?
yeah.
Yes, of course.
Okay.
Yes, so we can hear you.
Okay. Thank you.
You can
Let's
hear you.
continue. Let's continue.
Yeah, I can hear you now.
So the previous expression does not make sense in mathematics, but it is legal in programming. I like this language, legal. Understand? Madam, I dey hungry as I dey now. If I throw away for here, hope say una get wheelbarrow when I go take carry me go house. So let's continue, please. Now where I dey sef? You dey laugh. Okay. Timbadaku's office in Lemo. So don't mind me, abeg. So it is legal in programming. The expression adds 1 to the x variable, or we can say it increases the value of x by 1. So like I said, this is going to be x plus 1. This is 2, so it will assign 2 to x. Who be that now? Who is that? Mute. So now let's go down to, if you try to do something like 3 minus equals to x, nothing is happening here. You understand? Nothing is happening here. You are going to be getting a syntax error because at this point you are trying to assign a variable to a value. This is a value and this is a variable. Let me explain first. See here now, I'm having 3 equals to x. And if we scroll up to one of the rules we have, let me scroll up to the rules. See all these rules now. See this one now. A variable name must not begin with a number. This is a number here. This can stand as a variable name, but this cannot. So I'm trying to assign the value of x to 3. 3 is not a valid variable name. I have not even declared 3. You cannot declare 3 as a variable. You understand? So this is wrong. In case they ask you now for exam. So let's. Are we content content? Oh, come on, sir. So now someone is at the door. Arithmetic operators. Basically, they are used for arithmetic operations. No long story. So to compute inputs from users and to generate results. Sometimes this input may not necessarily be from users. It might be you, the programmer, writing inputs to your program. No long stories. So we need to use various mathematical operators at some point. So in Visual Basic, except for plus and minus, the symbols for operators are different from normal mathematical operators, as shown in the table below. So in the order of precedence as well. So as we have board mass, in mathematics, bracket of division, multiplication, addition, and subtraction. So these are the ones we have. So actually, in Visual Basic, we are going to be having something like P, E, we are going to be having D. After the D, we'll be having the modulus. No, this my M is wonderful. So we're going to be having the modulus. Oh God. Oh, manager. The modulus, we are going to be having the integer division. So we are going to be having addition. Wait, where's my eraser? So we are going to be having addition and subtraction. Actually, this addition and string and this and here is used for string concatenation as well. It is a popular programming question, and if you ask for exam. So this plus sign, what are the two things you can use it for? It is used for addition and concatenation. Don't forget. So this P stands for parenthesis. You understand? The E stands for exponentiation, like all these things you are seeing here now. So the third one is multiplication, division, modular division. Now let me explain this modular division. This modular division, for example, 15 mod 4 equals to 3. Let me use this 15 mod 4 to explain. I believe we understand this first thing. Now, if I have something like 15 and I'm dividing it by 4, normally, my answer is going to be 15 over 4. That should be 3 remainder 2, I guess. It should be 3 remainder 2. I think this is wrong, kind of. Because modular division is going to be taking the remainder, which is 2. This is supposed to be 2, not 3. I'm sorry. This is supposed to be 2, not 3. Now, but if you are talking about the integer division, we are going to be taking 3, which is the whole number. You understand? You will throw away this one. Let me look for another example I can use to.
It's actually 3 remainder 3. Not
3 remainder 3.
Yeah.
Wait. I'm coming, please.
15 divided by
So
4.
it's
4 times 3 is
3
4.
remainder 3.
Wait. Yeah. It should be 3 remainder 3. That's my bad. When I know vex, you don't take away with the book, I beg. When I know vex. So, 15 divided by 4. Normally, it should be 3 and the remainder will be 3. When I don't mind my 3, I beg. So, the modular division is going to be taking the remainder and it is going to be doing away with this one. But if you are working with the integer division, they are going to be taking this whole number. You understand? For example, 19 backslash 4, which is integer division. So this is going to be 4 and the remainder as well. And the remainder should be 3. So since this integer division, you throw away the remainder, you take the whole number. So this is concatenation here. For example, visual and basic, we give you visual basic. 2 plus 3, 4. So let me clean all this rubbish. I hope we all understand.
Yes.
So let me scroll. I'm trying to perform an arithmetic operation here. So let's go to our Visual Studio. I wish there was something I can do about this, the font size. No worry. So the x as integer, y as let me say integer, and also z as integer. I want to use something very, very simple for us. So I can say x equals to 5, y equals to 12, and z equals to 7. Let me clean all these ones. I can say, I can do something like console dot write line. I can do x plus y. Let me copy this one so I can paste. Copy. Let me do x minus y. Paste this one. X multiplied by y and x divided. What am I divided by? That's my divided by front slash. I was looking for this thing. I'm sorry. I was looking for this thing on my keyboard. So I think we are good to go now. Oh, sorry. So carry out this one through. Save and run the program. See what I'm getting here. So x is 5 and y is 12. So x plus y, which will be 12 plus 5, is given 17. So x minus y, which is 5 minus 12, is given minus 7, negative 7. So x multiplied by y, which is 5 times 12, will give you 60. X divided by y, which is 5 over 12, will give you all this rubbish. So I believe we all understand all this code here. We don't need it for now. So now we have the logical operators. Now in Visual Basic, we have the following logical operators. We have the Boolean operators and are also called logical. So we have the symbol and we have the name. Normally I'm supposed to tabulate this thing for us. I'm supposed to tabulate it for us, but when I'm managing like this. We have and a logical conjunction. You understand? We have a logical conjunction. This and this must be true for and to work. So this and also.
Don't show in again.
What's your screen again?
Can't see your screen.
Hey.
Sir, explain again.
Your screen is not showing again, please.
Kind of small.
Sir, can you just explain it again?
Okay. We cannot see my screen now, huh?
Explain
see
it
it.
again.
Okay.
You can see it, just explain it.
Alright. So, okay, no, this wasn't what I was explaining. I was explaining logical operators. Now,
Yes.
the AND operator, AND, it stands true if two statements are true. For example, let me say, what two statements are true? What two statements are true? 2 is greater than 3. Wrong. Okay, let me say 3 is greater than 2 and 10 is greater than 7. This is true and this is true. Wait, let me write. If I do something like 10 is greater than 7 and 3 is greater than 2. If I do 10 is greater than 7 and 3 is greater than 2, all these things here, since it is true and true, I'm going to be getting true as my result. So, but if I do something like this is greater than now, if I just clean this one and put something like maybe less than here, this is not true. So this is true and false. And this is logical conjunction. Both statements must be true. So this is going to result, instead of true now, it is going to be false. I hope you understand.
Yes, sir.
So this is going to be false. Oh my God, my E. So it's going to be false. Let me clean all these things so we can continue. Now, and also, this one. Somebody will ask me this one. Although I can't even remember what it does. But I'll get back to us on this. So, or logical inclusion. If one of the two statements is true, then the two statements are true. For example, this same example I used. If I say 10 greater than 7, and I said or 2 equals to 3. Don't let me use equals to for now. Let me still use the greater than. You see, this is true. Understand? This is true. And this is false. So, true or false is going to be giving you true. But don't forget, if it were not or, if it were and, you understand? If it were and, then the answer you are going to be getting here, true and false, is false. So that is just it. That is it. So we have the XOR, logical inclusion. I think this XOR is true for, I can't remember. I think none of them needs to be true. I can't remember. I'll get back to us on this XOR as well. So this not stands for negation. For example, not true, we give you bad. Not bad, we give you true, good. So that is what this not stands for.
You skipped or else short circuit.
Or else that short circuit. I can't remember what it is now. I'll get back to us on this and also or else. These two. I'm going to be getting back to us on it. I can't remember what it is. So Boolean operators are used to work with truth values. You understand? Truth values are true or false. You understand? So let me still use this one. Is x greater than? Is x less than? So let me comment this out and comment this one too out. If I save it and run it. You see what I'm getting? False and true. Let's do the calculation. What is x? X is 5. What is y? Y is 12. So x 5, y 12 is 5 greater than 12. False. So is 5 less than 12 true? That's why we're getting true here. Simple. So let's go back to our mystery PDF.
Excuse me, sir. Can I ask a question?
Ask.
Yes, on my phone here, I can't see that your laptop very well. In fact, I can't really see it. It's not really cool.
Badmos, take your screen and zoom in.
Excuse me, sir. Sorry, please.
Okay,
How
yeah.
did you? Excuse me.
One after the other.
How
Please.
did you? Okay.
Make
Can you
una
hear
talk
me,
now. I dey hear you.
Sorry, please. How did you comment those two out?
Yeah, I use them single quote. Yes, that's what they call it. Single quote. Your enter button on your keyboard, the one immediately to the left. I know Sabi speak English again. Immediately to the left. From your enter key. I bet just take care like that. Just go to your keyboard. You want to here. I go soon come out to you now. So this one wants to enter. Now this equal to sign. I want to explain something about that equal to sign. You see this equal to sign now. You can use it to check if one the value inside a variable is equal to another value. For example, let me come to my console here. If I do something like equals to, you see what I'm having here? False. It is because 5 is not equals to 12. Understand? So what if I say x equals to 5? Save.
It's going to be true.
You see what I'm getting? True. Why? Because the value stored in x is 5, and this value I'm comparing it to is also 5. So those are the two things you use this equality sign for. Now, it is an assignment operator, and it's also a logical operator. Don't forget. This one is no, it's not a logical operator. I think it's a relational operator. It's a relational operator. All these operators here, they are just these two. I'm still going to get to relational operator, so I'll explain better. Just know that this sign here, this operator here, it is not just for assignment. It is also a relational operator. So let's continue. Many expressions return a Boolean value, so they are used in conditional statements as well. In our next class, I guess, we are going to be talking about if-else. So now, the body of the statement, all this rubbish. Leave this one. So I'm looking for. Come in, please. True and true. All these ones. Okay. This PDF, I didn't take my time to compile it together. That's the reason why. Okay, the negation operator is what he's trying to explain here. That's the negation operator.
Sorry, please. Hope you are going to give us a PDF.
I'm still thinking it. Okay, I think I explained the and also or else. These operators are short circuit evaluated. Short circuit evaluation means that the second argument is only evaluated if the first argument does not suffice to determine the value of the whatever blah blah blah. All this one just throw away. I'll get back to us on it. I have to go and read it myself. Okay. So we have relational operators. I was talking about relational operators the other time. We have the symbol and we have the meaning. Hope nobody's knocking. You don't knock fire. So we have the symbol, relational operators. We have the symbol and we have the meaning. So this is a symbol, less than. So this is another symbol, less than or equal to. This is greater than or equal to. Then we have equal to. I think I made a mistake the last time. It should be double equal to. But let me go and check. Because let me see if it's supposed to be double equal to. Save and run. Okay, I think it should be single equal to. This is correct. Save and run. Yeah, it should be single equal to. In Python, I think it's double equal to. So someone is knocking. So this is symbol and the meaning. All these things here. Let us go and try them out. So is x great? What is greater than I guess? Is x greater than 5? Than y? So is x less than y? Let me remove this comment. As well. Is x greater than or equal to y? Is x less than or equal to y? So let me copy this too. Control copy. Come here, take it to the next line. Paste it. Is x equal to y? And is x not equal to y? Save it and run it. So you see everything we have in here. So x equals to 5, y equals to 12. So I've explained this to you the other time. Let me bring my distance back. So x is what? 5 and y is 12. Is 5 greater than or equals to 12? Obviously no. So it's 5 less than or equals to. You understand? Just like I was explaining the OR operator the other time, the OR. If one of them is true, then it is true. Less than or equal to. If any of them is true, then it is true. X is 5 and Y is 12. X is less than 12, but it's not equal to 12. So that is it. So this equality sign here, X is not equal to Y, obviously, and X is not equal to Y. So let's go back to our guide. So as we already mentioned, the relational operators return Boolean values. So this comparison operator equals to, okay, it's not like this in C and some other C influenced languages like Python, Java, and all. So now notice also that relational operators are not limited to numbers. You can also use them for other objects as well. You understand? It is not limited to numbers. So you can also compare alphabets as well. This thing here, you see this thing, let me copy it and use it. This might be an objective question. This line you are seeing here now. You will think it is not a correct expression.
Where is this?
You will think it's not correct, but it's actually correct. This is A, you are comparing to B here. You understand? So save it and run it. So this is true, this last one. Now let me explain the reason why this is happening here. You see the ASCII value of A and the ASCII value of B. That is what you are comparing together. And the ASCII value of A is less than the ASCII value of B. What is ASCII? I think it should be ASCII. CII values. So it is the ASCII values that you are comparing together. Let me go to images. I should be able to get a table for us. The ASCII values. The ASCII values. Open image and later. Oh, this is quite small. Wait. Okay, I think it will be clearer now. Yes. Open image in real time. No. Let me open here. So see the ASCII values we have here. This is capital letter A is 65. But the small letter A, where are the small letters here? You see, this small letter A is what? 97. And small letter B is 98. So these ASCII values are what you are actually comparing. So it's the reason why you have A less than B printing true. So returning true rather. So what exactly happens here? Computers do not know character or strings. Ask your questions. Ask your question.
How do they expect us to know that?
To know what? How did they expect you to know what?
The values of these things.
Remember that your FSC 113 book that you bought from Computer Science Department. If you remember that book, if you open the book to some page, I can't remember now. There is a page in that book. I can't remember the page now. There is a page in that book where you have a table like this. I can't remember the chapter or the page. So all these ASCII values, but the part I will advise you to cram in your head. Just know that 0 is at 48 and 9 is at 57. So since you have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 48 plus 9 is 57. So from just that, you can be able to trace other ones. You understand?
Okay.
So A to Z as well. A is 65. Z is what? 90. So from A, 65, you can always trace any other one.
Okay.
The small letters as well. So let me see if there's any reason. Ask first.
How about say it was like 5 letters together?
5 letters together. You look for the ASCII values, none. No, wait. It depends. Wait. It depends on the question. They used to give questions like that as well at the back of that book. But I don't remember how they bring the questions exactly. I can't remember how if you have the book and you have a place where they open that where they ask a question like that. Maybe I should just get back to you on it. Yes, I can hear you. I can hear you.
Like the one you showed us now, the ASCII value of A is less than the ASCII value of B. Can you hear me?
I dey hear you. I dey hear you. I can't hear you again.
The one you showed us now, the ASCII value of A. Can you hear me now?
I can hear you.
I know you showed us now.
Uh huh.
The ASCII value of A is less than the
Yes, the ASCII value of A is less than the ASCII value of B.
Okay, now what about the ASCII value of BA
As in, is it equal?
is it less than? Can I get better?
Ah,
Yeah?
I know, like if you, I know they understand your question.
Okay, sir, I saw it.
Okay. Okay.
Okay, they said the ASCII equivalent of the word rose, and there's a couple of long binary numbers.
Okay. I can't remember how to solve that thing, but I think it is to add all the ASCII values together. Then after adding it together, you get the binary value of the. You divide by 2, 2, 2, 2, 2. Oh God. Now this is what you do. This is what you do. This is what you do. You get the ASCII value of all those characters. You understand? After getting the ASCII values, what you are supposed to do is that you will add all those values together. After adding the values together, you will convert it to a number in base 2. That number in base 2 is your answer.
Sir, can you say it again? Sorry.
Step 1, get the ASCII values of all the characters in the word. You understand? After getting all those ASCII values, it's been over a year I did a calculation like that. I hope I'm correct. So, well, I stand to be corrected, but this is what you should do. I don't know if it is. So, get all the ASCII values of the characters of the word. Then after that, you should add all those ASCII values together.
Sir, I can't hear you.
Can you hear me now?
Yes, I can.
Okay. Get the ASCII values of all the characters in the word. Then after getting all those values, you will add all those values together. Then after adding the values together, what you have to do is that you will convert the total, your result, into a number in base 2. The number in base 2 is your answer. Everything you are saying there is 0, 1, 1, 1, 0, 0, 0, 1, 1, something.
It's so long.
Yes, it's very long. So just convert the number to a number in base 2, and you are good to go. This is Emmanuel Ojedokun. Off your camera. Emmanuel Ojedokun, off your camera. Thank you. So, I believe we all understand this one. We are almost done actually. So. This thing here, let's see what it does. Oh, let's see what it does. This last, so I think I can just comment this one out. Save this and run it. So, see what we have here now. Just this particular line, these last 2 lines. Now, A is, I'm having this coily bracket, open and close. I put 0 for the middle. Then AXC, A. So this is the ASCII value of A, if we check. Where's my browser? This is the ASCII value of A. Where is that A? 97, and the ASCII value of B is 98. That is what is happening here. The ASCII value of A is this, and the ASCII value of B is this. That is what that statement is saying. So, you can also in your program actually look for the ASCII value of, output the ASCII value of a character. So, internally the A and B are numbers. So, when we compare 2 characters, we compare their stored numbers, you understand? The built-in ASCII function. So, okay, this is ASC function. It might be an objective question. The ASC function returns the ASCII value of a single character. So when you are comparing the two numbers together, this A and B together, what you are comparing now is actually 97 with 98. You understand? So console the right line AB greater than AA prints true. So say we have a string with more characters. If the first characters are equal compared to the next one, in our case, the B character at the second position has a greater value than the A character. This B has a greater value than this A. So that is why the AB is greater than the AA string. So comparing strings in such a way does not make much of sense, but it's technically possible. So this is operator as well. It might be they might ask you in objective. This is operator here. This is. So you use it to check the equality of two values. The equality of two values. So see what I have here. O1 and O2. Then I have O3. So O3 is here and O2 is here. So this object data type, they don't really ask much question about it. They don't ask much question about it. So,
Hello.
I dey hear you.
Sorry, sir.
I dey hear you.
Board or something? I can't see.
You said?
You're referring to some things, then I can't see.
You can't see. I'm still presenting. Can you hear me? I'm still presenting.
Okay. Okay, sir. Okay.
Can you hear me? Oh. So
yes, I can hear you, sir. Thank you so much.
this object operator, they don't ask much question about it. But what I'm particular about here is that is operator is what I want to talk about. So let me comment all these ones out. Let me comment. Comment, and also comment. So I have this save and run. No, I think the is used on new objects. Wait, I don't know the reason why this is giving me error. Let me just copy this and paste it there. The is operator, it should be, I think it's used to the operator check. Okay, if two object references refer to the same object, yes. So it does not perform value comparison, yes. It is used on objects. That's the reason why it's not working. I'm sorry about that. So I can actually take away all this. So paste this. So use it to check O1 and O3. Where are you? Let me just copy this. Copy and paste. So save it and run it. Where is the build error coming from? Okay, this line. Save it and run it. There should be no build errors. Yes. Now see what I have here. O1 as object. I assigned a new object instance to it, and this instance as well. I've assigned it to O2. Now I'm saying O3 equals to O2. Now is O1 also pointing to the same object reference as O2? And O3 as well, is it pointing to the same object? Is O3 pointing to the same object as O2? That's the reason why this is false and this is true. One thing is that O1 and O2, you have declared them as two new objects. So obviously this is a separate object, this is a separate object. They cannot be pointing, O1 and O2 cannot be pointing to the same object in particular. So that's the reason why we are having false here. So this is
Chris.
O3. I dey hear you.
Chris,
I dey hear you.
I beg. Let's keep to time because of those managing their data. Let's keep to time. When it's time, please let's end the class, please.
I know you are.
Alright.
We are almost done now. Just 2 minutes. And even the guide where they use, we don't almost finish. See where we did. So I believe we all understand this is operator. I believe we all understand how it works. This is a separate object. This is a separate object. So O3 equals to O2. You have assigned O3 to the same object reference as O2. So is O1 equal to O2? Obviously not. Is O3 the same thing as O2, like we did here? According to this, our result it is true. Why? Because we have assigned to each other before we started comparing. So we are almost done. So okay, that is the end of the. I believe I've explained all this. So thank you very much for coming to this our online class. We really do appreciate your attendance. If you have any questions, I think there are groups. I'm on year 1 groups, so you can always ask your questions on the groups. As for the PDF, I'll be sending it across to us. Wait, let me send it. I'll be sending us the PDF. So thank you very much. We can start removing ourselves now. Thank you.
Thank you.
You're welcome. Oh, God of Nazareth. You say? I define where I want to end the beginning now. Where is it? No, leave call now with them.
You don't end call.
No. As I rejoin now, some people still there. No, there's no need. Everybody that they come out of it. So my Camtasia. See?